Alright, let's take a look at how to solve this log equation. Now, before we dive into the solution, let's understand what's the key feature here. Well, in this equation, there are log expressions on both sides, and the variable x are in the arguments. To solve this type of equation, our strategy is to combine and simplify the terms in this equation to have a single log expression on the left side and a single log expression on the right side, both with the same base. So if we have log A on the left side and log B on the right side, if we have log A equals to log B, then we know that A must equal to B. Then we can eliminate the logarithms and get a simpler algebraic equation. So how do we get there? We're going to rely on those logarithmic laws. These laws are our tools for combining and simplifying those log expressions. Let's start from the left side of the equation, 3 log x minus log 2. Notice that we have a number 3 in front of the first log expression, 3 log x. What we need to do is we can use the power rule to move this number 3 in front of this log expression into the arguments. Okay. Then it becomes log x cubic. Then we have minus log 2 equals to log 2x squared on the right side. Now on the left side, we have two log expressions with the same base, which we assume is 10 since there's no base explicitly written. Now we can combine them using the quotient rule here, which says the subtraction of two logs can be changed to a single log expression with quotient of their arguments. Applying this rule, we'll get log x cubic divided by 2, which is the argument of the first log expression divided by the argument of the second log expression. Now we've simplified the left side into a single log expression. Now let's look at the right side of this equation. And luckily, the right side is already a single log expression. We don't need to do any manipulation here. Let's just write it down. Log 2x squared. Now we've achieved our goal. We have a single logarithm on the left side and on the right side, and they both have the same base. Since the logarithms are equal, we can equate the arguments. Now x cubic divided by 2 equals to 2x squared. Now we have a simple algebraic equation to solve. Let's multiply both sides by 2 to get rid of the fraction. We're going to have x cubic equals to 2 times 2x squared. Then we get x cubic equals to 4x squared. Next, let's move all the terms to one side. X cubic minus 4x squared equals to 0. Then we can factor out the x squared, bracket. For the first term, there's only one x left, and for the second term, it's only 4 left if we take out the x squared, then equals to 0. This gives us two possible solutions. So the first solution is x squared equals to 0, which means x equals to 0. Or the second solution is x minus 4 equals to 0, which means x equals to 4. All right, the last step, we need to check our solutions in the original equation. For x equals to 0, remember we cannot take the logarithm of 0 or any negative number. For a logarithmic function, we know that x must be greater than 0. Okay, therefore x equals to 0 is not a valid solution. Then we have only one valid solution, which is x equals to 4. Okay, to recap, remember that the key feature of this equation is that there are log expressions on both sides, and the variable is in the arguments of the log expressions. To solve this type of equation, we need to combine all logarithmic terms to have a log expression on both sides with the same base using the logarithmic laws.